Hi, everyone. Thank you for joining us today in this session on how to build a custom CM solution using Azure AD B2C and third-party ISVs to meet your business needs. My name is Irene, and I'm joined here today with my wonderful colleague, Chad Hasbrook. We are both program managers from the Microsoft Identity Division. So, understanding the importance of alliances, we have built an ecosystem of third-party ISVs. Currently, we are focusing on these 5 core areas. 1. Enabling custom email provider for every customer. 2. Enabling an ID verification, liveness detection, and fraud detection through our ID proofing partners. 3. Bringing governance to Azure AD B2C. 4. Expanding our options for first and second factor authentication. 5. Last but not least, improving security functionality by adding additional protection against bot attacks, account takeover, and fraud.
That's a great list, but what are third-party ISV alliances so important?
Good question, Chad. There is more to identity and access management than just authentication and security that is provided by Azure AD B2C and its identity protection. For example, in a seemingly simple and typical user journey, to do an online car rental like this one, there could be a lot of services running behind it, from Azure AD B2C to bot attack detection and prevention, custom email verification, multi-factor authentication, ID verification, and even fraud protection. Now that we understand the importance of the alliance and ecosystem, next Chad will be going through the general CM architecture to implement Azure AD B2C and its ISVs.
Thanks, Irene. I spent actually a lot of time with the ISV partners building these connectors. Today, we're going to focus on 2 types of designs, server-side and client-side only. Server-side only is a service-to-service communication between the ISV service and the Azure AD B2C Identity Experience Framework, also known as IEF. Whether it's identity proofing, security analytics, or governance, this communication is handled through backend calls and is configured via the IEF policies. Now, when it comes to client-side only, this communication happens purely on the front end of the service. Client-side only means the front end of the service, using something like JavaScript, will perform REST calls to the integrated ISV service. This usually involves collecting data during sign-in or sign-up and processes prior to the Azure BDC executing the IEF policy. This does not require configurations within the IEF and is handled CORS enablement via JavaScript. With this being said, it is acceptable for the ISV service to have a mix of the two. Now, let's walk through each design and explore what's going on behind the scenes. Starting with the sign-up experience using server-side only architecture, I'm going to walk through each step of the process so you can really understand what's going on throughout the flow. Let's assume the BDC provider has already registered an application and published the endpoints. Starting with step 1, the authentication request from the client, native app, or browser is received. Because the BDC supports multiple policies, the request includes the policy ID in the P parameter within the URL. This is used to identify which policy is going to be executing. At this point, the request has been received by the bdclogin.com endpoint. Followed by step 2, the policy engine validates the OIDC request against core store app registration within Azure Active Directory. Then in step 3, the policy engine executes the BDC policy URL. Policies are stored in the Azure Blob storage, partitioned by the tenant. The policy engine evaluates the specified P parameter that was provided earlier into memory and sequentially executes the following steps. The next couple steps are all about branding. In step 4, the policy engine inserts the HTML controls in the JavaScript onto the client browser. We will replace certain divs on the page that is used for displaying the essential B2C controls. If the div is corrupted, controls will not show up correctly. If the name of the control changes, it may break. This is why we use page contracting to prevent breakage. In step 5, the JavaScript of the client browser pulls the HTML from the custom HTML stored into the content delivery network, also known as CDN, and merges those that are stored within the policy engine. This is what provides that custom branding that you see on the page. Followed by step 6, the user self-asserts in the UI via an email. A user clicks sign up. Note that email validation is optional. If the email validation is required, the policy engine will generate an OTP. The OTP is sent by the multi-factor authentication service, or MFA for short, via email or SMS, phone. Now, this is where the ISV comes into play. Things get a little more interesting. Once successful, the Azure BDC in step 7 will perform a RESTful API call to a middle layer API where it passes the user information. The middle layer API handles formatting, optional business logic, and protocol mapping. This request ultimately is forwarded to the identity proofing service. Once received, the identity proofing service processes the information, determines the validity of the user authentication, then it returns the result back to the middle layer API, where again it reformats, applies optional logic, and provides the response to the BDC policy engine. Note that this is purely optional, having this middle layer API, but it's commonly used with a lot of the ISV connectors. Now, at step 9, assuming the ID proofing is successfully based on preconditions, the policy engine performs a graph API call to write the user profile information into the core store to create a user object in Azure Active Directory. The policy engine completes the user journey, ultimately issuing the token from Azure BDC, whether it's a JOT or SAML, to the client, and the user is authenticated within the application. Now, unlike the server-side design, client-side only happens on the front end of the service. This means IEF never handles the REST call. Let's take a closer look at the sign-in experience with the ISV. For completeness, we will run through the first part a little quicker, but focus mostly on the differences between the two architectures. Again, we will assume the BDC service provider has already registered an application and have published the endpoints. Starting with step 1, the authentication request is received and reaches to the BDC endpoint. The Azure BDC validates, looking up the app registration. In step 3, the policy is executed based on the policy ID. In step 4, Azure AD BDC starts with a custom UI workstream. Step 5, JavaScript pulls down the custom HTML. JavaScript and merges with the deltas. In step 6, the user signs in with the optional multi-factor authentication. Followed by step 7, the Identity Experience Framework authenticates against ESTS, which is our Evo services that handles the tokens. Now, this is where things kind of change quite a bit. In step 8, once the user hits submit on the sign-in page, they're presented with a challenge via the client. The result of this challenge is sent to the API service that generates a token that is immediately passed back to the client. In step 9, the front end of the client then in turn sends that token, which is signed and contains the results, to a second service that validates, unpackages, and sends the results back. Note that this is one type of approach. Azure BDC does not require this multi-step process. We have been flexible enough to accommodate certain ISV requirements when setting these type of connectors. In step 10, the information is securely passed to Azure BDC Identity Experience Framework. This is where you can add in additional logic. Say, for example, if they meet some type of standard, you can do multi-factor authentication or even call a second ISV connector. Step 11, ultimately, then when completing the user journey, is issuing the token back from BDC to the application or client via JOT or SAML application. The biggest difference, everything is happening outside of the Identity Experience Framework and purely on the front end. It's important to note that some ISVs may use a combination between both designs to successfully connect to their service. Azure ADBC is flexible enough to accommodate each service, therefore it makes it an ideal platform and candidate to future technologies. With that, I'm going to pass it over to Irene and ask her to provide us an overview of what we have discussed so far.
Thank you, Chad, for the explanation. In this video, we have learned about the ISV ecosystem and the architecture flow. As next steps, to learn more, please go to aka.ms/external identities partners. And we also would much appreciate your feedback at aka.ms/AD user voice. Thank you.
Thanks, everyone. We'll talk to you next time.